Welcome to Study Loop.
Okay, here we have two pendula, one that is starting at a height h above the other, which is at rest at the equilibrium. They have both the same length of 50 centimeters. M1, which is the one that is h above M2, it weighs 2 kilograms. M2 is 3 kilograms, and the height difference is 10 centimeters or 0.1 meters. The frequency of any pendulum going through a small angle is 1 over 2 pi times the square root of g over L. In this case, L is 50 centimeters or 0.5 meters. We get 0.7 hertz. Okay, so that's the easy part. That's part A. For part B, we need to start off with some energy conservation to figure out how fast one is when it strikes two. So we know that M1 GH equals 1/2 M1 V1 squared. The M's cancel out, and we get that V1 equals the square root of 2GH equals 1.4 meters per second. All right, now we need to use momentum conservation to figure out the speed of the combined masses after collision. So the initial momentum is M1 V1, and this equals M1 plus M2 times big V. So big V equals M1 V1 over the combined masses, which is 0.56 meters per second. So now we can use energy conservation again to figure out how high the combined masses go. So big M G H1, which is the height after collision, equals 1/2 big M, which is the combined mass, big V squared. M's cancel, and H1 equals V squared, big V, over 2G equals 0.016 meters. So we need to figure out the angle, and to find the angle, we can draw a triangle here. So we're going to go up to some height. So this here would be L minus H, and this is L. This is theta. Okay, so then the cosine of theta will equal L minus H over L equals 0.484 over 0.5. And we take the cosine inverse of both sides to get theta equals 14.5 degrees.